We are presenting this as an educational session on how to think about modern compute as we move to the cloud. We look forward to sharing some thoughts, suggestions, use cases, and example architectures. Hopefully, you're able to take these learnings with you as you think through your own modernization efforts. And during this presentation, I'll be joined by Todd, who will be doing a deep dive into the app modernization journey of one of our customers. With that, let's look at the agenda now. So we'll first discuss the need for modernization and evolution of architectures. We'll explore the computing options you have when looking at cloud native architectures. We will then go deep into containers and serverless, and then look at how some of our customers are using serverless and containers for their modernization goals. When we asked our most successful customers what do they want from us, here's what we heard. They're looking for ways to enable quick innovation and faster time to market. They're looking for reliable, highly available, and scalable applications and infrastructure. And they want the highest security and isolation, and all of this with a lower cost of ownership. Now, we see customers modernizing applications to improve their return on investment, reduce total cost, and increase the efficiency of developers and their agility. And the biggest barrier to innovation is the lack of time spent on what matters. Now, Gartner talks about the fact that 80% of IT spend is focused on running the business, while 20% is focused on innovation. The fastest way to improve that ratio and bias it towards innovation is to get rid of the undifferentiated but expensive activities like managing infrastructure. It's not a one size fits all, but modernization brings opportunities to optimize for growth. Here's how application architectures have evolved to keep up with the demands of the modern business and the application landscape. Traditional architectures have been dominated by the concept of monolithic applications before they evolved into microservices based architectures. With a monolithic application, you're often limited to a single technology stack for the entire app, shared release pipeline causing friction at many points of the life cycle, interdependencies on shared libraries, and even the smallest change causes the entire app to be rebuilt, retested, and redeployed. On the other hand, microservices based architectures can be deployed independently, where each service owns its own data and is not tightly coupled to any part of an overall solution. Each service can scale on its own and set its own SLAs. This makes it easy to migrate the individual services to newer and better technology stacks because of the lower impact to the overall workload. Now, microservices existed before the cloud, but cloud allows to easily make use of them. Once you have identified the monolithic application that has a high business value with associated high cost, you can start thinking about breaking it apart into microservices. This was the same pattern that Amazon.com used when they were no longer able to scale their application. Back when it was a monolith, it took weeks for code changes to go through the development lifecycle. After modernizing to a microservices based architecture, Amazon was able to achieve over 150 million deployments per year. When we are building out the microservices, in most cases, we can't simply eliminate the monolith right away. We need to do it over time until it is able to replace all the capabilities that was once part of the monolith. This is where the strangler fig design pattern comes in, a modernization approach coined by Martin Fowler, who is one of the authors of the Manifesto for Agile Software Development. There is an interesting anecdote on the origin of this design pattern. When Martin went on a trip to Australia, he noticed the strangler figs growing on the trees. They seed in the upper branches of a tree and gradually work their way down until they root in the soil. Over many years, they grow into fantastic looking shapes, meanwhile strangling and killing the tree that was their host. We will be applying this design pattern in today's hands-on lab. Here's an example of the strangler fig pattern applied to an application architecture. Both the monolith and the microservices will live in parallel for a period of time as you build new capabilities outside the monolith code base. This newly developed service will present you with an opportunity to architect the microservice in a way that best suit the needs of its job. Its intention is to do one job and do it extremely well. You'll continue moving out capabilities from the monolith until it's all replaced by microservices, at which point you can then eliminate the monolith application. Let's look at the way compute choices have evolved over time. Not too long ago, and in some places even now, there are organizations who prefer to maintain their own data centers. As a consequence, they're not able to leverage all the innovation that's happening in the cloud. They need to renew the hardware regularly to keep up with the pace and have an upfront capital expenditure before they can do any innovation. Then there is a good set of customers that are moving to the cloud and leveraging virtual machines. And the reasons why customers move to the cloud typically starts with cost, with pay for use pricing model, but we believe agility and innovation are the more important reasons. You can quickly spin up infrastructure for an experiment fearlessly and terminate it if it does not work out. This increases the amount of innovation that happens in your company. There is no need to do capacity planning ahead of time due to the elasticity cloud offers. You can quickly tap into all the innovation happening in the cloud, and you can leverage the global infrastructure to make your application available across the world. The third wave is of containers, which gives you a high degree of mobility. You're running something on prem and want to keep those investments, yet be able to run in production in the cloud. Containers make it possible to package your applications and move them between different computing environments. It starts a lot more rapidly than the VMs, and you get this highly flexible toolchain, but you're still managing servers, updating the operating system, and patching it. Customers running containers who don't want to manage servers can choose AWS Fargate, which is a serverless compute engine. And then there is AWS Lambda, which is at the highest level of abstraction. With Lambda, you build your code and let AWS worry about the infrastructure. As a result, it enables customers to move the fastest. In addition to thinking about compute options, it's also important to think through all other layers of applications. While AWS is responsible for protecting the infrastructure that runs all of the services offered in the AWS cloud, customer responsibility will be determined by the service that they select. Let's look at the various choices you have through the lens of the shared responsibility model. By choosing services that you see on the left here, you retain most of the operational responsibility. As you move towards adopting services on the right, you start offloading more of the undifferentiated heavy lifting to AWS. And on the far right are the services where we abstract away all the complexity for you. For example, customers who choose to deploy an Amazon EC2 instance, either for compute or for self-managing database or Hadoop, are responsible for management of the guest operating system, including updates and security patches, and any application software or utilities they install on those instances. In the middle, you see some of our managed services, such as Amazon RDS, which is managing the work involved in setting up a relational database. It takes care of provisioning the infrastructure capacity, performing backups, and patching the database software. In the messaging layer, Amazon MQ provides a managed message broker service that takes care of operating your message broker, including setup, monitoring, maintenance, and provisioning the underlying infrastructure for high availability and durability. And services on the right that provide the highest level of abstraction, such as AWS Lambda, DynamoDB, and S3, is where AWS operates the infrastructure layer, the operating system, and platforms, while customers access the endpoints to store and retrieve data. Customers are still responsible for managing their data encryption options, classifying their assets, and using security tools to apply the appropriate permissions. Our goal here is to provide you more choice and also to provide you a path to modernize so that you're responsible for less and we manage more of your infrastructure. This will free up your time to focus on improving your business outcomes. One of the important choices you will make in your modernization journey will be around application architecture and compute strategy. Let's start exploring the options you have around those. So here you can see the similarities in the approaches between containers and Lambda. It's important to note there are no wrong choices here. In many of the most important ways, ECS, EKS, and Lambda give you the same benefits. All three services are fully managed by AWS. All three services have deep integration with AWS automation and deployment services, networking, storage, security, observability, and the AWS ecosystem of partners including Docker, Terraform, and Datadog. And all three services support a broad range of use cases and workloads. But there are some distinct differences and nuances that you need to be aware of as you come down this path. First, Lambda is event oriented. This means that it sits idle, ready by your side until an event is triggered and the system has to jump into action. Once the event is triggered, resources are spun up to meet the need of the task at millisecond speed, and it also spun down when it's no longer needed. There is no need to worry about the infrastructure, provisioning, or configuration, and you literally pay only for what you use. This means faster time to production with the lowest possible TCO. Containers, on the other hand, are compute oriented. This means it has similar constructs to a physical server or a VM, but what makes it different is that it allows customers to turn monolithic applications into modular, portable, and composable services. By creating these bite sized services and using container orchestration services like ECS, EKS, infrastructure becomes a lot easier to manage and reliability and resiliency increases as you're removing single points of failure. Unlike serverless, containers still give you the options to define and pick your resources and type of services for your application. While you still only pay for what you use, a container is instance based while Lambda is request based. And the reality is that most customers are using both containers and Lambda because rarely do customers have only one single need. Most of the time, the decision on compute isn't really an or, it's an and. And T-Mobile is a great example. They built a serverless developer platform and they use Lambda for a lot of customer facing apps. But they also use Kubernetes for their always on applications. And the results speak for themselves. T-Mobile was able to grow both their NPS and customer base with a strategy that enabled them to use the right tool for the job. Let's look at some ideas on selecting containers. So when you need applications with non-HTTPS listeners, you need stateful applications, you need an agent, daemon, or a sidecar to run alongside your service, any support for Windows containers. When you want hybrid scenarios or on-prem portability, you need container image portability with Docker runtime and the ability to purchase different billing models, such as on-demand, reserved instances, and spot. One of our customers, Snap Inc., embarked upon a modernization journey and broke up their monolithic application by adopting Amazon EKS and ECR, and they now run over 2 million transactions per second and reduced the time it takes developers to launch new services by 77%. Once the infrastructure is provisioned, you will need an orchestrator to provision and manage the containers and containerized applications. And you have options when it comes to the orchestrator. If you want to go all in on AWS, ECS is a great option, simplifying many decisions with an opinionated set of automations. A video and analytics platform provider for coaches and athletes to quickly review game footage used Amazon ECS to generate player tracking data with a simple but highly scalable pipeline, adjusting the cluster size to balance cost and processing time. This machine learning process used to take over 5 hours in batch mode, but now can run faster than near real time. On the other hand, if you want open source flexibility and to bring in the whole community of tools, EKS brings Kubernetes to AWS. A customer who built a technology platform to create kid-safe digital engagement grew from 2 Kubernetes clusters to more than 20. This led to additional complexity, and to keep things simple and manageable, they switched to Amazon EKS, and this allowed customer to keep the benefits from all the features of Kubernetes without the hassle of managing the clusters themselves. Many customers run a mix of all three. Another customer who was a subscription health service provider, they enable users to have virtual consultations with doctors and healthcare professionals via text and video messaging through a mobile application. They chose Fargate for EKS to shift the focus from running and operating complex orchestration platforms to operating a secure and scalable health system. This maximized their engineering effort both in terms of time and money. Now let's look at some ideas on when serverless might be a good choice. General rule of thumb is if the workload is event-driven, stateless, and not a long-running task, it may be a good fit for serverless. So here you can see some scenarios such as IT automation, microservices, data processing. So when you need lightweight application-focused stateless computing, or you need to focus on business logic, not IT operations, you need to enable real-time data processing or a serverless backend and reduce complexity for development and operations. Serverless is a great choice. Comic Relief, a major UK charity, went serverless on AWS and can now process up to 350 donations per second during peak broadcast moments while achieving a 93% cost reduction. And getting more specific into what is Lambda, which is ultimately an event-driven compute service, to understand Lambda, you need to understand what we mean when we say events. In the simplest terms, an event is a signal that a system state has changed. In most modern systems, these are represented as JSON messages that provide some set of facts about what changed, potentially what the current state of the system is, and what action needs to be taken. Event-driven architecture is an architecture pattern that uses events to trigger and communicate between decoupled services and are commonly found in applications built with microservices. The more you decouple services, the faster you can scale. Customers who leverage event-driven architectures adopt serverless microservices faster. Serverless customers like Netflix, Liberty Mutual, and Taco Bell all began their serverless journey with event-driven architecture first. And industries like airlines, quick service restaurants, and banks, they're all event-driven, and they often recognize the value of serverless. We feel strongly about the benefits of event-driven design because it can improve reliability and scalability. Events are asynchronous. You don't need to wait for a response to move on to the next step. This improves resilience and reduces dependencies. The tools of event-driven architectures are routers that abstract producers and consumers from each other. You can publish to the router and consume from it without knowledge of other producers or consumers. Event routers at AWS include EventBridge and SNS, and event stores act as buffers, holding on to events until the consumer is ready to use them. At AWS, SQS is our serverless event store, or a queue such as Amazon MQ, and it uses standard APIs and protocols such as MQTT and WebSockets. With this, let's now head into the Lego deep dive. I would like to invite Todd to talk about Lego's modernization journey. Hey, Todd.
Hey, everybody. How's it going? Todd Schaefer. I am a serverless specialist covering startups here in the Americas. And today I'm going to speak with you a little bit about Lego. Me personally, got a little prop here. I'm a big fan. Some of you may covet a Lamborghini or something to that effect. But for me, it's an old school 1970s VW bus, and at current, I live in New York City, so I don't exactly have parking available. So that Lego kit that I think was about 1,000 pieces is about as close as I'm going to get for now. So I'm definitely a fan of not just the monolith, the microservice journey that they've taken, but I'm a big fan of their sets as well. But let's talk about kind of how they ended up on this monolith, the microservice journey. Back in 2017, they extended their web application out to the front end of AWS. They put a Node React app out front, routed it through a VPC back to their data center that was a Oracle ATG e-commerce system backed by a relational database on SAP. And they went to Black Friday of 2017. The front end scaled as they expected. However, since the back end was not nearly as elastic as the front end, ultimately the service became unavailable. And if you know how frustrating it is to see a 40% off deal on a kit that maybe you've been anticipating for a while going on sale, all of a sudden to have that kit unavailable for order, I can only imagine Lego fans like myself were pretty upset, and Lego felt the pain as well. So during that introspection process, they really thought about, okay, so how are we going to build a truly elastic infrastructure? And what they decided on was to kind of choose a system, one of the myriad of systems internally at Lego, and they nominated their tax calculation system. So it was kind of a perfect alignment where their tax calculation system was prior a server-based application. But they were migrating them. The tax software was actually migrating towards a SaaS-based offering via RESTful API. So it kind of offered itself as a great test. And so what they did is they routed out the requests using a feature flag. So that's the ability to dynamically direct traffic, between systems without really interrupting, kind of the front-end user experience. And so, given this was kind of a read operation, not a write operation, it worked really well for a feature flag. And so they set up API gateway with some Lambda functionality to go make a call to the tax system and calculate wherever in the world you may have been and the taxes that needed to be collected for that country. And they experienced such a great level of success with that particular small project. They've since gone on to really go all in on serverless across the entire portfolio. But let's start breaking this down kind of bit by bit. So the first use case after the tax system was the shopping cart. So you have another use case. It's pretty good to decouple, where customer wants to put a kit, and in this case, I can see it's the Bugatti, into the basket. And in there just needs to be a really quick validation of did it work or did it not? And so here we just have the atomic request response model, where you have a consumer or a customer that hits an API gateway, whether that's through the phone app or the e-commerce site. It's all kind of based on APIs and just different skins applied. It invokes a synchronous call to a Lambda function, and then really quickly puts it into the shopping cart. And so this is super simple. It's performance over everything. We just want to make sure that customers can successfully log things into the cart. It's a very simple logic evaluation. So just either the thing can go into the cart or it can't, so there's not a partial failure. It's not a big multi-step process where, maybe you're building your own Lego set piece by piece, and if one piece was missing, all of the pieces had to get removed from your cart. And they just needed kind of a binary 1-0 success or error response. So just a super lightweight, easy pattern here. And then going into kind of or Ramesh, do you have any questions on that?
Yeah, usually I would recommend customers to start with something simple. This does appear slightly complex with a variety of systems interacting.
Well, I mean, this is ultimately a pretty simple, overall process. You just have a quick check of, is item available? Is item not available? Right? That's all the logic, and it's just hitting a quick cache, asking like, hey, is this thing in stock? 1 or 0? If in stock, put into the basket store. If not in stock, do not put it into the basket store. So I would say more on the the tax system. I could certainly agree that was not the simplest swap in the world there, but for the pattern here on the atomic request response, this is a pretty straightforward process. But we'll make it a little more complicated for you, Ramesh. So the next case is something's in your shopping cart, and you want to know the status of your order. So this is a bit more complicated, and this is a CQRS pattern, or a command query response segregation pattern, which is not new to serverless. This particular pattern has been around for a long time, and in fact, you'll see that a lot of patterns that you implement on top of serverless have been around for quite some time. But let's walk in order of kind of how it works here from left to right across the top. A customer, says, hey, I want to understand, I want to process my order. That goes into the submit order function, and then that submits that to a submit order queue. From there is a process order function that pulls items off of that queue and then goes through a process of pushing to the payment provider. And then what else is marked here is actually migrating that user to a new commerce platform. We're not going to get into that right now, but I wanted to focus on kind of that submit order queue, process order function, payment provider portion of this architecture. And the reason that using queues and kind of separating the responsibilities here is so important, let's say that the payment provider goes down for a minute, 15 minutes, whatever it may be. What you don't want is for there to be a fully synchronous call of submit order function going directly to the payment provider in the event of a payment provider going down, because what that would end up in is lost orders. And so instead what it does is it puts it in that durable queue, and then it's picking them off as everything is available. And so in this way, you also protect your payment provider, because you can add in some throttling in the put in a little bit of throttling in the actual submission to your payment provider. Your Visa, MasterCard, whoever it is on the receiving end of that may not enjoy a million requests per second being submitted to their API. So sometimes you'll find with your partnerships, your downstream API RESTful endpoints may also have some throttle requirements. And this is a great method to not just increase durability, but also to, kind of treat your partners kindly in respecting the amount of throughput that they would appreciate at any time. From there, in the process order function, it drops into an order cache based on DynamoDB. And what we're doing there is using a pretty short time to live on that order status. So that's, if you look down at the bottom part of the screen here, you can kind of see all of the different order statuses that would be possible throughout that, and you're really just looking for the most recent status when you go to check your order, which we can now look at the bottom part of the flow here. And so I'm impatient. It's Black Friday. I got my 40% off. Lego Starship, shout out to Rucker there in the chat. Lego Starship in my cart, and immediately I'm sitting here going refresh. Where's my stuff? And so what this is doing is it's going through and it's checking that query status. Now, depending on who the requester is, so I should know all of those statuses, right? Because it's my business. I'm the one that ordered it, and I'm the one that owns the credit card. And so for me, it would be be useful to know that in my holiday shopping bonanza, that my card was declined and that I need to provide a different level of payment. However, different systems that are kind of going through automated checks really just need to understand processing failed or complete. So, depending on who's requesting that API endpoint is going to give a different level of detail across that request. And so this is a overall, a pretty solid pattern for implementing, an order processing flow. Ramesh, any questions here?
Yeah, so considering now that the original reason was the Black Friday high spike, so if that kind of a high spike happens, how would this architecture handle the scenario?
So, in the event, ultimately what you're looking at is every single piece of this architecture is going to kind of dynamically scale along with the requirements. So, the first portion here, that submit order function, is a really fast call. It's just submitting the order and sticking it in that order queue. So, that being kind of the most we'll say volatile part of the architecture, you can scale up almost infinitely, big asterisk there. There are some confinements inside of there and some quotas. But ultimately, this allows for all of these orders to get submitted, that Lambda can start, firing out, hundreds of thousands of concurrent connections, and then getting all of those into the queue. And then, the most important thing here is that queue can accept, all of those orders, and then the process order function, which is downstream from there, can then kind of have a breather from the kind of the onslaught coming in through the front end. So yes, this definitely helps with, being able to independently scale the functions within there. I am looking at some questions in here. So Ramesh, we've got some maybe not softballs, but let's see what we got. So CQRS, a pretty complicated pattern, looking for use cases where it makes sense. Okay, so in a CQRS pattern, really what you're looking to do is you're looking to separate your writes from your reads, right? So anytime that you're dealing with databases, especially, or data stores of any kind, usually you have, some contention for the read and the write. And so in this particular flow, you could have flattened it. The submit and the order status API could have been the same, but then you would have had contention on, checking statuses and submitting orders. And as one of the primary goals of an e-commerce provider is to ensure that these orders are going through, it was best for them to separate those out. So I'm actually not familiar to the level of whether or not they actually started this out as a singular function and then migrated to a CQRS pattern. But certainly I have seen customers that had too much happening in a singular Lambda function, too many reads, too many writes, and things like that going on in one bit of logic. And, best practice is to kind of break Lambda functions into the most functional but most discrete at the same time singular function that you can. So in this regard, since they really wanted to make sure that submitting order was going through, above all else, even at the sacrifice of maybe checking the status, because if I refresh one time and I didn't immediately see that my transaction's complete, it's not the end of the world. But if I had not had my order processed and actually submitted, and then the thing went out of stock, then I would be upset. So you can kind of feel through where maybe a singular function versus a CQRS pattern amongst dozens and dozens of other patterns that work here would make sense. And then another question from V here is, can't we send the request directly from the API gateway to the queue instead of submit order function in between? You can, and Ramesh, you're the solutions architect on the call, so keep me honest. You would be able to directly submit it to a queue. That said, you wouldn't have any of the logic between there from the API gateway to the queue. So, with the submit order function, you want to make sure that there is still stuff in stock. So there is so that there's actually a physical item behind that order. You want to make sure that's there. So although you could wire it directly to the queue, in this case, there needs to be some logic between the API and the actual queue. And then read replica and CQRS, that could take a good 15 to 20 minutes. So Isaac, we can get together with an essay after the call for that one. And the order cache and TTL expiry. So DynamoDB, and I'm not a DynamoDB pro, I'm a Lambda pro, I am a SQS pro, like that's my world. We have plenty of professionals on the DynamoDB side, but ultimately, part of the cost associated is the amount of storage that you're keeping in Dynamo. And since these are ephemeral statuses, you know, there's only going to be ultimately a few statuses that matter in here. Processing failed, complete. If processing, you know, we know that we're going to expect another. And so what you can do is you can just kind of lock down the amount of storage that's in there, and you're really just making sure that for each, you know, customer order, there is one status, you know, and it's the most recent status there. So, and then you can expire out anything that is not the most recent. And then, you know, additionally, after, you know, so many days of having a complete status, you know, the order has actually been shipped and landed on the you know, a customer's front doorstep. Therefore, you know, there's no more reason to keep anything in the order cache. So that's kind of how they're managing that. And Ramesh, I believe your questions have been asked for you, sir. So I'm going to move on to the next slide.
Yeah, absolutely.
And so the next use case is voucher code generation and notifications. So when you're operating an e-commerce site, and there's actually a number of use cases that use this that aren't, you know, voucher codes specifically, but ultimately you want to be able to reward customers for their, you know, for their patronage. You know, I should maybe pick up some more kits from Lego. Maybe I would get these coupons, but you know, ultimately you want to be able to incentivize folks for shopping at your site. And so one of the ways to do that is to produce a bunch of voucher codes and email those voucher codes out to your customers and say, hey, limited time only, you know, X% off of the things that you've been expecting. And so we're going to explore a little bit of a pattern on how to do that. So some quick notes of what's going on here. You know, we're going to go down that center line from the admin user through the API, through those couple of Lambda functions. But first, a quick note on, you know, what's happening here. So this is an admin user facing feature. So this is not customer facing. This is a, you know, a team of less than 5 people that even have access to this tool. So there's not a whole lot of fault tolerance built in. There's not a lot of durability. You're not going to see queues. You're going to see some, you know, quasi anti patterns in this. But, you know, ultimately, when we build software, there's only so many hours in the day. And although we would love to build everything super elastic and durable and everything else, sometimes you're just kind of you're just trying to build a quick tool. And in this case, this is one of those cases. So the admin user gets a call or an email or a Slack from their, you know, from their business partner over in the marketing department. They say, hey, we need 1 million voucher codes for these types of customers. They all need to be unique, and you know, let us know when they're done so we can email these things out. Admin user says, cool. Hits his quick internal tool, hits that API, goes through a synchronous call to that request handler, and then goes to an asynchronous call to the generate voucher function. And this may be a place for those experienced in this space going, well, wait a second, Todd, you got a Lambda calling a Lambda. Like, isn't that a bit of an anti-pattern? Again, I refer back to how this is being used, and I'll explain why this is the case. So here, the request handler is accepting that call from the API. Now, a little maybe it's a known fact, but when you're making a call to anything beyond API gateway, there's a 30-second timeout on the high side. And you know, you can actually lower it from there, but you can't necessarily raise it. And so, you know, what you're really looking for in the request handler is a 1 or a 0 of got it or don't got it. I have the request, I don't have the request. And then the request handler fires over to this generate voucher function, which is an asynchronous function, because we don't know how long it's going to take. So in the case of like a 1 voucher production, you could have just gone from the voucher API over to the generate voucher Lambda, because it would have happened, you know, within a second. You know, the whole thing would have happened. But in the you know, the space where we're generating millions of these vouchers, you know, it may take well beyond 30 seconds to produce all of those. And so that's why we have a synchronous to asynchronous call. And then once the vouchers are produced, it sticks all of those in a DynamoDB voucher table that's kind of saying, hey, these have been requested, redeemed, partially used, whatever it may be. Again, there's a TTL on this particular voucher table because coupons are only good for so long. But going from left to right again, just to kind of take all that detail out, admin user, voucher API, request handler to the generate voucher. Vouchers are generated, stuck in the voucher table, and then a file is submitted to an S3 bucket on a signed URL. And so what this is a securely accessed URL that you can only have if you have the right key combo. And then once that generate voucher function completes, it shoots a quick note into the SNS voucher topic, and then that fires out an email to the admin user and says, here is your secure bucket with your million coupon codes. Email these off to whoever you see fit. And then the admin user Slacks emails back, or however they need to communicate that that URL to the S3 bucket, and off they go. Certainly there's ways to automate further beyond this, but since it was a pretty lightweight simple tool, this was all they needed for this particular architecture. So I got a Ramesh, I'm going to cut in with Joseph, who's been asking good questions here. Joseph asks in the chat, what does that async call from Lambda to Lambda mean from an implementation perspective? Do you put it in an S3 bucket queue, etc.? So the synchronous call is what the API is, the conversation that the vouchers API gateway is having with that request handler. So saying either I received the request for generating the vouchers, or the API gateway just kind of times out and there was no response. If we'll say that the Lambda was unreachable or whatever happened there, and so the admin user at that point knows, okay, we're going to try again. And so from the asynchronous is really, when you're not, when you kind of move into event-driven architectures, really what you're looking at is, a lot of asynchronous handoffs where maybe the other services behind that originating request don't even know, don't know anything about the vouchers API. So in this case, the generate voucher doesn't know about API gateway. It just knows that 1-0, I got a request for making some vouchers and how many vouchers I need to produce. And the reason that, synchronous one is because there needs to be a value given back to the admin user. If I got, the success notice. And then the asynchronous function is really that production of millions of voucher codes, which takes time. And then, the other action that's happening is eventually that file is written to that S3 bucket. And so both of those things, those are separated from that original request. So I can kind of walk away, go make an espresso, and then sit back down. And at that point, maybe I've received the email. Maybe I need to go make another espresso, and then I'll have the email in my inbox. And so that's kind of the difference between the synchronous and asynchronous. How are we doing on? Yeah, processing is async, exactly. So Ramesh, I don't know if we have time for more questions on this one, but feel free to fire away if you've got one.
No, I think we're good, Todd. Thanks so much for such a brilliant explanation of Lego's transformation. I think we'll head over into the summary slide here. So we saw how the strangler fig pattern was applied to decouple the backend. We saw how the CQRS design pattern helped streamline the order workflow. And we looked at the voucher code generation and notification workflows, elegantly handled how they both security and scale. These were small but important pieces of Lego's journey. They continued to innovate and eventually tied everything together into a cohesive strategy. And the architecture you see on this slide is a new hub and spoke design that makes it much simpler to operate events rather than using point to point connections. And we talked earlier about how integrations are essential in leveraging Lambda. Here you can see how Lego uses EventBridge to act as a central event hub for Lambda functions. We have these QR codes on some of the slides that you can use to learn more about these case studies. And thanks again, Todd, for clearly articulating the thought process behind Lego's modernization journey. Let's look at some additional use cases that we see customers building with containers and serverless, ranging from legacy app modernization, refactoring monolith applications, Customers, if they have a legacy app, we see them typically leveraging containers for a migration path, while some other customers choose to completely refactor their legacy applications and choose to go with Lambda, Fargate, and event-driven architectures. For in the AI ML space, we see use cases around autonomous vehicles, robotics, healthcare, such as medical processing. Typically, these are time and process intensive processes and handled by container services. Now, with container image support for AWS Lambda, which was announced at reInvent 2020, AWS offers larger Lambda functions. And some of these use cases can be handled by Lambda as well, especially on the modeling and the inference side. Data processing applications are very common as well. Batch data processing applications are typically handled by container services due to a longer duration and longer processing nature. Real time processing, such as creation of sales dashboards or aggregating data from various systems for insights, are implemented by services such as Kinesis. They are typically complemented by Lambda, since Lambda has native integration with Kinesis and offers benefits for customers such as it's essentially serverless and scales automatically during the reshard operations. Another common set of use cases are around backends, such as for various custom applications and services, mobile backends, and IoT. And customers also leverage both serverless and container services to build static and complex web applications. We have already seen how Lego handled their web application. And we have also seen other customers such as Washington Post and Assurin, where they first they select services that best fit their use case. And in general, we're seeing Lambda being leveraged for net new application development if the app can be event driven, and Fargate is leveraged for longer running and process intensive workloads within that same architecture. Let's look at some additional customer case studies. So Nielsen Marketing Cloud is a data management platform built from scratch. They get data in and process it to about 100 different ad networks, requiring about 250 billion events per day. And they use Lambda to process files and fan out data, all while maintaining quality, performance, and cost using a fully automated serverless pipeline. At the end of the pipeline, they also rate limit the number of files to their ad partners to ensure they don't overload their partner networks. On a peak day, Nielsen receives 55 terabytes of data, requiring 3,000 lambdas running concurrently. Quora and Vidc were able to leverage our managed container services. Quora had Kubernetes expertise, and EKS simplified how they operated Kubernetes workloads. And for Vidc, ECS was the simplest and fastest way to get applications deployed with minimal operational overhead. Finra wanted to move on their on-premises Hadoop cluster to AWS because it was an operational overhead. It only ran in batches and couldn't scale easily. It was also idle 50% of the time. Using serverless building blocks like AWS Lambda, S3, SQS, Finra developed a serverless stock trade validation system in only 3 months. They increased cost efficiency by a factor of 2 versus their previous on-prem system. They also reduced their processing times and can now easily scale to handle up to half a trillion validations every day. Coca Cola is a great example of how a serverless strategy enabled agility when they had to react quickly to the changes brought on by the COVID pandemic. They wanted to provide a touchless experience for their freestyle drink dispensers. And so they built a new smartphone app that allows customers to order and pay for drinks without coming into contact with their vending machines. And because they built with Lambda, the team was able to focus on the application instead of having spending cycles on scalability and latency, since with Lambda, that's all built in. As a result, they were able to build their new application in just 100 days, and now over 30,000 machines have the touchless capability.
My name's Rob Bryant. I'm a solutions architect here at ClearScale. I've been here for about 4 years. And so today I'm going to talk about a couple of case studies just quickly. So the first one here is kind of a mid-market project we did. So everyone's heard about or heard of the Salvation Army. They've been around for more than 100 years. And they've back in 1891, they created these red kettles where they would go out and collect money to help children and families during the holiday season. So in the past, the red kettles have always collected cash donations, but recently the Salvation Army started looking into new forms of payment. They wanted to create and host a simple mobile donation app and website. And so they came to ClearScale to help create the mobile collection app, the backend infrastructure and website to be able to do this. They had a really tight timeline as the app and website needed to be ready to roll out by November before their holiday season began. And so this gave us at ClearScale just a little over a month to design the architecture, develop the app, deploy the infrastructure, and get everything tested and running. So what we did was we, for the backend and website, we developed an event-driven serverless solution using Lambdas, an API gateway, and CloudFront running off of S3. And so kind of the same type of a solution that we were talking about earlier, using API gateway and Lambdas. So with this solution, the new mobile donation collection capability allowed owners to scan a QR code there at the Red Kettle to open a website and contribute through one of several available payment methods. And we're talking about things like Google Pay or Apple Pay or other electronic payment methods. And so the Salvation Army did really good that year, and it was a very successful program. So they decided to come back the next year and engage ClearScale again to see how we might enhance that process even more. And so one of the things that they had learned that first year was that the donor experience was not as smooth as it could be. Not everyone's familiar with QR codes and would sometimes fumble with, being able to quickly and effortlessly scan the code, get to the site, make their payment. And so we proposed using NFC technology instead of the QR code to enhance that user experience. So we began piloting a NFC capability there at the Red Kettle and implemented a wireless bump to pay approach. And so the guest would then simply just bring their devices near the Red Kettle, and it would kick off a new functionality that would run the customer through the new payment process. And so again, that service was using that same event-driven backend, just on the front end, increasing or I should say, decreasing the level of effort for the customer to get started in that process. So that was one example of a project we did. Again, I should have mentioned earlier that these case studies are available on our clearscale.com website, along with well over 100 other case studies for projects, and you can search for them based on technology or type of project. So the next one I'm going to talk about is more of a container-based solution and just more of an optimization project. So Savvy Money is a fintech company that provides credit scores and personal finance solutions to banks and credit unions. They had previously ClearScale had previously partnered with Savvy Money to build their original AWS environment, and Savvy Money's credit score platform has seen amazing growth over the last 5.5 years, and the company signed up over 420 financial institutions across 34 different online and mobile banking platforms, and they were expected to add another 10 to 12 institutions per month. And so while doing that, this was causing a little bit of a pain point for them. So working with specific platforms, multiple configurations of the same code were often required. And it was the increase in tenants also were causing a strain on their deployments and ability to quickly onboard new customers. And so ClearScale came back, or Savvy Money called ClearScale to come back and re-architect their SaaS platform. And so we came up with a solution to rebuild their infrastructure using containers, using ECS, and implemented a new tenant isolation and management system in place. And we also made some, UI modernization updates, some monitoring enhancements, but mainly we put in place a new CI/CD process. And so the new delivery pipeline is implemented through Docker container deployments on ECS using CloudFormation to easily deploy multiple environments for their customers. And the use, we also utilized managed services in multi-AZ configuration to ensure the platform's high availability. So we were using services, I've already mentioned ECS, but application load balancers, Elasticache, Amazon Aurora. And so trying to take advantage of as many managed services as we could for their infrastructure. The new solution allowed Savvy Money to make production releases with minimal impact on performance and no downtime, including when adding new tenants. So that entire build process can be tracked and significantly improve the feedback cycle, allowing Savvy Money to quickly extend its customer base and drive platform innovations. So again, another example of how modernizing your application and changing the infrastructure can allow you to focus more on innovation and less on managing that infrastructure. The next thing I want to talk about is the assessment that Kevin had mentioned at the beginning of the webinar. So we've done this offer before, and it's been really popular with members that have attended this webinar. And so this is an application modernization assessment. And so what we'll do is review your application portfolio, take a look at all of your applications and make recommendations for how and what to modernize. And so kind of give you those, what should you do first? What's the next step? And then we'll create a report of that assessment and the findings, and also give you a proposal if you would like ClearScale to help you with that. Again, this is funded by AWS, and so it is there's no obligation, no strings attached. We're not going to tie you into anything for doing this. And so again, it's kind of a thank you for attending this webinar. And again, it's 100% funded by AWS. You can access or sign up for this by either scanning this QR code here on the screen or clicking the link there on the page. I believe there's also a special offer that has popped up on your screen. And depending on where you are or how your organization works, if you're attending this and you need to get approval or kind of need to run this up the chain of command in your company, be sure to share this link with your managers or directors to see if they would be interested in doing something like this.